This next section is about inverse trigonometric functions. And let's start with the definition of inverse sine. So inverse sine is actually usually when you take the sine of an angle, that gives you the ratio of two sides. Actually, when we're doing the inverse of the sine, we are going to get an angle as the answer. So this definition looks a little bit tricky and confusing. We'll do a few examples in just a second. The key thing is that you usually start with sine of theta is equal to a value. In this case, if you were to do the inverse sine of that value, you would get back the theta. The other thing that's important is the values that we always get for our theta are between negative pi over 2 and pi over 2, which is the same thing as negative 90 degrees and positive 90 degrees. And one other important thing is that you often will see this written as arc sine of A. So if you see arc sine of A and inverse sine of A, those are the exact same thing. It's very important to remember that there's nothing different between the two of those. So let's do a few examples. And I have a unit circle here. I think that'll help a lot. So we're going to evaluate a few things. So the first thing that we're going to evaluate is inverse sine of radical 3 over 2. Okay, so if you remember when we did the unit circle, you might remember that we found stuff on the unit circle by remembering that sine of an angle was equal to the y-coordinate. Actually, in this case, if we would like to find the inverse sine of something, this radical 3 over 2 is going to be the y-coordinate, and we want to figure out where the corresponding angle is. So our answer is going to be an angle. The other thing that we know is that they tell us that we want our answers to be between negative 90 and positive 90. That means that we're going to be on this whole part of the unit circle right here. So it's at that area only. So you can ignore anything else on there for now. So what we're going to do is we're going to look on our unit circle, see if we can find out where the y value is going to be radical 3 over 2. And actually, the only place that happens in the range that we're allowed to do it is at 60 degrees. So our answer for this is going to be, you can either write it as 60 degrees, or you can write it as pi over 3. So just remember, we are looking for the angle. The second one I'm going to give you, I'm going to do kind of the same idea. This time I'm going to call it arc sine, but just remember, same thing. And I would like you to try to pause and see if you can find arc sine of radical 2 over 2. So hopefully you found it. What you're going to do there is you're going to look on your unit circle. You'll notice the only place where we have radical 2 over 2 is, for our y value, is going to be at 45 degrees or at pi over 4. So here's a little example where we're actually going to use inverse sine. So I'm going to ask you to find theta. I gave you a right triangle, and I also gave you the opposite, and I gave you the hypotenuse. So remember that the sine of a theta value is equal to the opposite over the hypotenuse. So in this case, we know that sine of theta is equal to 1/2. So the way that we can solve this problem is actually by using inverse sine. And you might remember from when you first learned how to do equations, the way that you solve them was always by doing the inverse of both sides. You're going to do the same thing here. So the way that you get rid of this sine of theta is you do inverse sine of theta of that side. You have to do inverse sine of theta of the right-hand side. On the left-hand side, actually, the sine and the inverse sine cancel each other out, so you're just left with theta. The right-hand side, you end up getting sine inverse sine of 1/2. Now you solve that problem, as with the previous one, by looking at your unit circle. You'll find that the theta is going to happen when our y value is 1/2, which is going to be right here at 30 degrees, or pi over 6. So that's one way that we actually are going to use it. Later on, we'll actually do some word problems that do involve finding this angle, and you'll get a lot of practice with it. So let's go through the definition of inverse cosine and do a few problems with that. So inverse cosine is very similar to inverse sine. The only difference is now you need to remember that with the unit circle, cosine of a theta is equal to x, so the x coordinate. The other thing that's good to know is that our answer that we get for theta is going to be between 0 and pi, or 0 and 180. You'll notice that actually the x values are going to, that's the only place where we can go where we have different x values for all of our possible things on the unit circle. So let's do an example. I'm going to ask you to find inverse cosine of radical 3 over 2. You can feel free, if you want to do it on your own, you could pause, or I'll just do it otherwise. So inverse cosine of radical 3 over 2 is going to occur where our x value is 3 over 2. You'll find that that actually happens right here at 30 degrees, or pi over 6, so that's my answer for that one. And I'll give you another one. So the next one I have is arc cosine of negative radical 2 over 3. And you'll find that that occurs at 3 pi over 4, or 135 degrees. And sometimes I'll ask you to give me the answer in radians, other times in degrees. Just make sure you know what the difference between the two is. So the next one is inverse tangent or arctangent. This one you'll find is a little bit harder because on the unit circle, tangent of a theta is actually y over x. So it's not as easy to figure out the point immediately, but it's not impossible. So the other thing that's important is that this one is going to happen between negative 90 degrees and positive 90 degrees. That way we'll get both positive and negative tangents, or values of tangent. So for the first one, for the first example, number 6, I am looking for the arctan of negative 1. Remember, that's the inverse tangent of negative 1. So what I'm looking for there is I want to figure out where I have a value of y over x where I have negative 1. That's what I'm looking for there. You'll actually find that that's going to happen at radical 2 over 2, negative radical 2 over 2, because if you divide those two things, they are going to give you a value of negative 1. So for this one, my answer is going to be, it's at 7 pi over 4. Unfortunately, that's not in my domain. So if you want, you can write it as negative 45 degrees, or you can write it as negative pi over 4. So then for number 7, this one's a little bit harder. I have inverse tangent of radical 3. So for that one, you might need to work it out a little bit on your own. We know that this has to be a positive value because if you look at your negative angles, they're going to give you a negative tangent. So we want to figure out where our y over x is equal to radical 3. You will find that that is going to happen at 60 degrees, or pi over 3. If you aren't sure about that, you can always go back and you can actually look at 60 degrees. You can look at these values. If you do y divided by x there, you will get radical 3. So we're going to evaluate a few more things. For number 8, this one, believe it or not, is really easy. So cosine of the inverse cosine of radical 2 over 2 is, guess what? Just going to be radical 2 over 2. Now, for number 9, this one's a bit harder. So sine of the arc cosine of radical 3 over 2, it takes a few more steps. So the first thing you need to figure out is the arc cosine of radical 3 over 2. Remember that we are looking for an angle. So the angle that you're going to find is going to be when the cosine is radical 3 over 2, which occurs at 30 degrees. So we're going to put in sine of 30 degrees. The next thing that you need to do is you need to actually figure out the sine of 30 degrees. You'll find that one by just looking at the y value at the same place, so your answer for that one is 1/2. So my next problem is one of the harder ones. I want you to first notice that we're looking for arc cosine of 2 over 3, which would give us an angle. However, you'll notice that on our unit circle, we don't have 2 over 3 listed. The reason we don't have that listed is because it's not one of the nice angles. So we actually have to do a little bit more work for this one. And I'm going to go ahead and do it on the next slide. So for this problem, the first thing I just want to remind you of is that this is an angle, and it's an angle I'm going to call theta. If you want, you can ignore the tangent for now and rewrite this as theta equals arc cosine of 2/3. Or theta equals inverse cosine of 2/3. This means that this is the same exact thing as cosine of theta is equal to 2/3. These two equations mean the same thing. The only difference is that they're just written in a different way because arc cosine and cosine are inverses. So now what you can do is you can actually draw a triangle that represents this value. So my triangle I'm going to get is going to have theta right here. It's going to be a right triangle. The adjacent side, because remember cosine is adjacent over hypotenuse, the adjacent side is 2, the hypotenuse is 3. Now what we can actually do is we can use this triangle to find the tangent of theta. So the way that we're going to do that is we need to find, remember tangent is opposite over adjacent, so we need to find the opposite side. This actually is not too bad because my opposite side, I'm going to call it b and use the Pythagorean theorem. And when you do that, you end up getting that b is equal to radical 5. So now what you're going to do is you are going to now just find tangent of theta. The answer for that one is going to be radical 5 over 2. And actually, that's the answer for the entire problem. That's all you have to do.